Hello judges, my name is Adrian and I'm the team leader of this team. This is Sherming, this is Wei Hong, this is Justin, and this is Sherlyn. These are all the team members of our team.
Greetings judges, we are the participants of Hengi High School, Malaysia. The COVID-19 pandemic is life-threatening, so we need to get a continuous supply of vitamins to improve our immune system. Consuming vitamin tablets or health supplement is a common way to improve our immune system. However, this is not always affordable for certain groups. Literature research shows that microgreens can provide 9 times more vitamins and minerals than vegetables. What are microgreens? Microgreens are small consumable vegetable greens harvested just after the cotyledon leaves after 7 to 14 days.
Our project aims to study the factors of increasing the production of microgreen within a limited space to benefit our community. Green pea, commonly known as pea microgreen seed, are used in our experiment. They were separately grown hydroponically in 5 10 cm times 10 cm tray. The first objective is to determine the ideal seed density to maximize the yield of harvested microgreen. Secondly, we have compared the harvest time and the mass of microgreen with and without the ultraviolet treatment during germination. Thirdly, we investigate the relationship between light intensity and the mass of microgreen harvested for green pea. Based on the objective, we have constructed 3 null hypotheses and 3 alternative hypotheses. Firstly, seed density does not affect the microgreen production during planting. Exposing to UV light does not affect the microgreen production. Lastly, light intensity does not affect microgreen production.
Now, let's move on to the methodology of our experiment. For the first experiment, we need to determine the optimum seed density for green pea microgreens. Green peas are separately grown in water in different number of seeds. 60, 70, 80, 90 and 100 number of seeds are placed evenly in 100 cm square tray respectively. Then, we put those seeds above water which will change it every day. On the 14th day, the microgreen will be harvested and weighed separately. The result will determine which pair of seed density will produce the highest mass of microgreen. For the second experiment, two trays of green pea seeds are prepared using the optimal number of seed density. One tray is left under the UV light for 30 minutes to germinate, while the other one is left to germinate in the dark. The day when the true leaf first appeared is recorded for each tray respectively. On the 7th day after the true leaves first appear, the microgreen were harvested and weighed separately. For the third experiment, 8 trays of green pea seeds are prepared using the optimal number of seed density. Each tray was placed at 8 different locations within the house. The light intensity for each location is recorded every 2 hours from 8 AM to 6 PM for 14 days. The average light intensity for each location is calculated.
Now, let's discuss our project's findings and analysis. In our first experiment, we want to find the best seed density in a 100 cm square container. As a result, 80 seeds per 100 cm square planting space yield the maximum amount of microgreens gathered. You might be asking, isn't it true that with more seeds come more microgreens harvested? No, since too many seeds in a growing tray will compete the basic needs such as space, sunlight, and water. Next, we will discuss our second experiment, which compares the harvest time and the mass of microgreens collected with and without UV therapy during germination. With UV treatment, harvest time was shortened by 2 days and the mass of microgreens harvested increased by around 11%. Let's now proceed to the final experiment, which found the light intensity affect the mass of microgreens gathered for green peas. According to this graph, the best light intensity of plant microgreens in order to increase their mass is between 1800 to 1950 lux.
Here are some discussions that can be made throughout our research. Firstly, our findings show that on a level of confidence 0.05, it is statistically significant that the first null hypothesis, seed density does not affect microgreen production, is rejected. Microgreen production is affected by seed density. Interestingly, there's an optimum seed density to increase microgreen production. Secondly, our results also shows that on a confidence level of 0.05, it is statistically significant that the second null hypothesis, exposing microgreen to UV light during germination does not affect microgreen production, is rejected. Pea seeds after exposure to UV light before planting could shorten the harvest time and increase microgreen production. Thirdly, on a confidence level of 0.05, it is statistically significant that the third null hypothesis, light intensity does not affect microgreen production, is rejected. Pea growth is different under different light intensities. Our result shows that a suitable amount of light intensity is required to produce more microgreens. We use square containers with 100 cm square growing space in our study. Optimum seed density can be calculated accordingly to planting when using containers of different growing spaces to increase microgreen production. In conclusion, our project allows the community members to effortlessly produce microgreens in numerous small pots within a limited space, such as our home, their work office, or even the school. Therefore, we can easily boost our immune system. Thank you!